Before we continue expanding the functionality of our channel, let's take a look at how we debug Roku channels. For newer developers, debugging is vital to understanding the Roku platform. It provides insight into the runtime environment and helps you understand the behavior of SceneGraph and BrightScript APIs. As you develop your channel, you'll need to diagnose and fix bugs, and fortunately the Roku platform includes a built-in debug console that includes crash logs, stack traces, channel performance metrics, and an interactive debugger. In this lesson, you'll learn how to access the debug console via Telnet and the Roku Eclipse plugin, and you'll learn how to access the different debug ports. You'll then learn how to view the crash logs, stack traces, and channel performance metrics in the console. Finally, you'll learn how to use the interactive debugger to type commands for checking and updating variable values, calling functions, and stepping through the application. You can access the debug console via Telnet or the Roku Eclipse plugin. Let's start with Telnet. On a PC, you can use a shell application such as PuTTY to connect to Telnet. I have a Mac, so I'm going to use Terminal. Let's enter Telnet, the IP address of our Roku device, and then the BrightScript debug port, which is 8085. The debug console also includes a special SceneGraph port, 8080, which includes utilities for logging thread rendezvous, checking texture memory, and viewing node performance. But we're going to focus on the tools on port 8085. I can also access the debug console from the Roku Eclipse plugin. Now that we're connected to the debug console, we can take a look at it in action. To debug a channel, it needs to be sideloaded on your Roku device. I've already got the channel that we built in the previous lesson on my device, but I'm going to use the development application installer to delete it and reload it so I can show the console output as the channel is launched. When the channel is launched, the first thing you notice are the signal beacons. These are markers in the channel application that are used to measure the channel's performance. These signal beacons tell you, for example, how long it took for the channel to compile and launch. When I select a video, the video launch beacon measures the time it took to start video playback. These signal beacons are important because your channel has to meet specific channel performance metrics in order to be certified and published to the Roku Channel Store. Now, if your application has a bug and fails during runtime, the crash log will show you which file and line of code caused the crash, and the stack trace will show you the sequence of calls that led to the crash. So let's open the main loader task BrightScript file and insert a stop command after line 17. This will force the channel application to break before it starts getting the metadata from the content feed and adding it to the SceneGraph components in the channel UI. And then we'll save the file and use the Roku Eclipse plugin to install the channel. After I install the channel, the crash log in the debug console displays an asterisk on the thread and line of code where we stop the application, which is line 19. The stack trace provides a snapshot of the local variables at the time of the failure. It lists the component or data type, the number of references, the count, and the value stored in the local variable. And it shows the sequence of method calls on the different threads leading up to the failure. After the console displays the crash log and stack trace, the BrightScript debugger opens. The debugger has a pretty robust set of commands for diagnosing issues. Some of the commands provide the same information we saw in the crash log. For example, I can enter var to get the current types, counts, and values of the local variables. I can also enter print or the question mark symbol to print out a variable value. I can enter last to see which line was last executed, and next to see the next one. And we can enter threads to list all the suspended threads, or thread to pick a specific thread to debug. If you need a list of commands, you can enter help, or you can check out the debugging code documentation. Let's use some of the debug commands to view the metadata in the content feed and print out some information about our Roku device. So let's enter step, or the shortcut S, to step to line 22 in the main loader task file, where we start parsing the metadata in the content feed. This is stored as a JSON string in the JSON variable. And now we enter var to display the types, counts, and current values in the local variables. And now let's print out the current value of the JSON associative array variable, which will show us the movies, short-form video, and series RO arrays in it. And let's print out the movies RO array in the JSON variable, and then the first item in the movies array. Now we can actually compile and execute BrightScript statements right from the debugger. For example, I can create an RO device info object and use it to print out the resolution of our channel UI, the Roku OS version running on our device, and our device's IP address. When I'm ready to resume the channel application, I can enter the continue command, or the C shortcut, to start executing the channel's code again. Note that if my channel is running without any issues, I can open the BrightScript debugger by entering Control-C. This will dynamically break into our channel application.
Thank you so much for watching this video. For more Roku developer videos, subscribe to our channel. And for the rest of the videos in this course, as well as additional demos and tutorials showing you how to develop on one of the world's leading streaming platforms, check out the link to the Roku Developers video site in the description below.